I would now like to move on to our next session. It's a case study session for which I would invite Mr. Nitin Bhushan Prasad, Manager Operation Tata Power. Mr. Prasad has 12 years of industrial experience and is presently working at Tata Power. As an operations manager, he is looking after daily operational activities of PF-fired boiler, coal mills, boiler feed pumps, ACW system, DMCW system, cooling tower, maintenance activities of boiler, turbine side, balance of plant, and STG equipment. Thank you for joining us, Mr. Prasad. Request you to put your camera on and you could unmute yourself as well.
This is Tata Power JOJOBERA, myself, Nitin Bhushan Prasad. This is something about JOJOBERA power plant. Basically, we are giving most of the power to Tata Steel and the remaining power to Tata Motors, Tata Cummins, then Novoco and the JUSCO. Basically, I will be telling about the NOx abatement system that we have implemented in Unit 4 just before our ASD. In this system, basically, this is the kind of a digital boiler brush system which is being provided by GE. In this system, basically, they have placed the coal flow sensors in all over the coal mills, and it is collecting data with the coal flow sensors, and basically it is used to control the FAD, basically the fuel air dampers, auxiliary damper, and with the dynamic air pressure, basically it is controlling the CO and the O2 analyzers it is also having. It is this system basically benefits us in reduction in our NOx system, then reduction in our aux power, reduction in the dry and flue gas losses, and basically as the excess air is increased, so this is increasing the boiler efficiency of our system, and overall the plant heat rate improvement is there. As the excess air is controlled in our system, so this is able to decrease the aux power and finally the dry flue gases, and it is finally improving our boiler efficiency. This is second model is basically we have put a kind of catalyst that is named DFN catalyst in Unit 1. In this system, we have dosed a kind of chemical inside our Unit 1, and this was basically planned in the month of May 2022. In this, with the help of peoples, we have put some kind of chemicals that was provided by a DFM catalyst system, and with a loading of around, you can say, 1.2 liters, 200. Earlier we started with 200 milliliters per minute, but later on we have increased it to 1.2 liter, and the final impact of the system was the decrease, basically specific fuel that was decreased, and it was in the order of around, you can say, the graph that is 5. We started with the day 1. Day 2, we have decreased the specific fuel to 5.74, then 5.3, and there basically you can see that on an average 5.2 specific coal was decreased. In terms of heat rate, if we talk about, then heat rate, our baseline is about 2783, and day-to-day heat rate that we calculated with the reduction of the coal that was earlier, the baseline was 2783. Day 1 we achieved 2654 heat rate, and consequently, basically there was a decrease in the heat rate of around 4 to 5 kcal. In this process, basically we kept the load at constant 58 megawatt, and with the load and this pressure and temperature, everything was kept constant, and we found that there was a drastic decrease in the coal consumption, and finally the improvement in the heat rate. Basically, this trial we have done in Unit 1 of our JOJOBERA, that is 67.5 megawatt, and with the success of this system, we are trying to implement it in our consecutive units of Unit 4 and Unit 5, and this year and post that we will be able to reduce the heat rate. This is our project that we have taken in various units of Unit 4, Unit 3, and Unit 2. That is basically the de-staging of boiler feed pumps. Boiler feed pumps, that is the main heart of the plant and basically supplies water to the boiler. In JOJOBERA, we are having the boiler feed pump of 12 stages, and in this we have reduced 2 stages, and the motor capacity basically it is of 2000 kilowatt, and in at full load condition what we have achieved, that is around 12.5 amperes of 6.6 kV we have reduced. And individually, if we talk about the total saving of 25 ampere saving is there, and the cost, if we calculate, then it is around 60 lakhs per annum we have saved. And the ROI, the investment is around 1.3 crores, so ROI is around 2.17. So this is a very good auxiliary power saving initiative that we have done, and the same thing is implemented in Unit 4, post in Unit 3 and Unit 2. 3 units we are saving, and you can say around 1.5 crore saving per year is there with this boiler de-staging. Total auxiliary power reduction is of a 0.3% if we talking about 6.6 kV, and the net heat rate reduction is around 7 kcal. The third project is basically in our Unit 2 and Unit 3, both are having the common four-way and of a CW circuit, and we have found in our calculations that we were having leakage. We were having a difference in our what we are feeding in the raw water circuit and what we are evaporating. So finally, what we did that we thought that some kind of leakages are there most probably in the CW circuit, so that in this system we have appointed some kind of divers. So they have gone inside the CW four-way lines. This is the basically drawing. You can see that this is the Unit 3 city fan area, and this is the Unit 2 city fan area, and the common four-way that is coming toward the CW pump house. And in this drawing, the blue parts you are seeing, and with the marked one red marks, these are the portion that is basically, these are the expansion joints. And next slide I'm showing. See, in this portion, you are able to see that these were the location which were found with the expansion joint leakages, and the water was seeping inside the ground, and having major leakages. This is the basically the this is the aerial view of the cooling towers and the four-way. You can see in this aerial view that these expansion joints, the leakages were there. This is the live video when the divers have gone inside, and you can see in the video that clear cut the divers are fetching out that what kind of leakages are there inside. This is the water seepage inside the expansion joints later on, which we have attended. And this basically, all this system with the leakages, overall saving of, we would have around 1500 tons per day of water saving was there, and totally saving of 13.5 lakhs per annum saving was there in this process. This is one of the refurbishment plan that we had earlier. Basically, in JOJOBERA, we were having 8 number of compressors for instrument air and service air, and what we found in this, that basically all the compressors that were made to run at around 7 bar pressure, and we had a kind of air audit in the plant itself, and in that air audit we found we have calculated the every part, that whatever the PD pump is consuming, whatever the our consumption is there in ESP, then consumption in the APH, and overall in the system we have found out that the total conveying air of our requirement was 24,000 meter cube, and the installed capacity was 5,900. But what the major thing was that we were maintaining the system at around 7 kg. That was not required for conveying air, because conveying air and instrument air, that was mixed. So what we did that two number of compressors of unit 1 and unit 2, we have taken it out as a service air compressor, and more installation of two number of compressors in unit 5. With this, what happened, that conveying air system, we have made it a different conveying air system, and instrument air we have separated out. And finally, with the usage of this system, we were having a saving of around 1.75 crores in two compressors of, because basically we have reduced the pressure from 7 kg to 5 kg, that is the conveying air pressure. So the auxiliary air, so the specific power has reduced due to this, and we have got a good saving of this of around 1.75 crores. This is the saving. Basically, in the major system, there was a lot many leakages were there, drains were open. So all this system totally, we have trapped 20 number of drains. We have stopped it and made the trap points were made in that. And by arresting these leakages, we have saved around 4,900 meter cube of air, and overall a saving of around 6 lakhs was there. So this was our basically plan that we have made it various type of saving. Thank you.
Thank you, Mr. Prasad, for that. I will just check. There is one question from Paras. If DFM catalyst Is DFM catalyst a multi-combustion catalyst like Thermact?
Actually, this is a separate company that they have come. We cannot tell that what kind of catalyst that Thermax are using. But this catalyst, they have given us a good result. And still, this is in
yeah, thank you for the question. So I am along with Nitin, and I head operations at JOJOBERA.
Oh, good evening. If you could please introduce yourself and then respond to the question.
Yeah, I am Bimal Kumar, and I head operations of JOJOBERA. And I just came around 5 minutes back, and I saw Nitin delivering, so I just started listening. So regarding the query about DFM catalyst, it is actually named dual function material. Now this is a company from actually a US based company who is having a dealership, national dealership in India. So they approached us over here. They had a different concept, not like Thermax. They are with their chemicals. They have the natural the contents in the coal, the thorium, the chromium, and all. They do fission reactions inside the boiler. So with this fission reactions, it completes in a chain reactions form, and ultimately the heat energy inside the furnace increases. And if the heat energy inside the furnace will increase, so for the same load, actually we'll have to cut down with the coal consumption, because that heat is being liberated by the chemical itself. So it's all the play that how much chemical and how much coal. It's a balance. So if we are finding a financial gain with this chemical firing, say X amount of the charge for this chemical is something X amount, and the reduction of coal is at the same time more than this amount, say X plus Y amount, which is double than X. Now, since we are saving this in double form, so this thing is coming into actions. Now we have done the 2 trials, and we have found around 4 to 5% gain in specific coal consumption in overall. So while the company claims that it will go till 10%, right? So 10% saving in coal consumption, especially coal consumption, is really a big saving, which amounts in crores. For 120 megawatt, it is around 5 to 6 crores. So if it is successful, then we can implement it parallelly on all other boilers. So this is just an this thing, but there are many things in this actually. While we say GCV of the coal plays a very important role. Now this GCV cannot be a fixed value. Even if you fill up the bunker, some 200 kilocalories or 150 kilocalories keeps on changing. So whether the effect has this GCV effect has brought some help or the chemical. So ultimately, if we reach above 10%, then we can clearly, define that yes, this DFM catalyst is working and the fission reactions are working inside the boiler. So the ratio of firing this thing with respect to coal is a matter over here. So we are doing on adjustments in this, and we are finding a positive factor of 5 to 6%, which we hope by 4 or 5 months it will go to around 10%, and then it will be a clear win situation. Yeah.
Yeah, because there was a
The
follow-up
question.
question also, that how much boiler efficiency increases by dosing DFM.
That is what I said. If the coal consumption reduced by 5 to 7%, that will be the amount of gain if you convert it into boiler efficiency.
Right. We have one more question from Sudarshan Pradhan, that how do you measure boiler efficiency improvement? Is there a direct method or an indirect method?
By both methods we do.
Okay.
Both methods is used.
Sure. Okay, so with that, we will conclude this case study. Thank you for joining us, for making this presentation and for responding to the queries from our attendees today.